Welcome to my presentation on how do German science teachers characterize biological giftedness. My name is Anke Renger and I'm working as a postdoc researcher at University Hamburg, Germany, at the chair of the Didactics of Biology. In 2016, a joint initiative of German's federal government and German's federal states called LEMAS, meaning something like Students Performs Sets President, started. The aim of this initiative is to foster high achieving and potentially gifted students in regular school lessons. One of the 22 sub-projects focuses on STEM biology education and empirically investigates what characterizes biological related giftedness. The overall aim of the sub-project is to develop a diagnostic tool for biological giftedness and conveying tools. The concept of the giftedness has changed considerably in recent years, whereas in the past it often referred to cognitive performance aspects. Today, it is viewed much more broadly from a multi-perspective point of view. The aim of gifted education is therefore to provide optimal support for the development of potential in children and adolescents. This form of giftedness promotion up to talent or excellence promotion has already been successfully practiced in sports for decades. In the natural sciences and technology, this systematization of talent identification and development can still be expanded. A systematic talent identification and development starts in regular lessons at school. This aspect is addressed by the German project called LEMAS. LEMAS is a research and development project funded by the German Federal Ministry of Education and Research to promote high-performing and potentially high-achieving students. Research shows that these students have individually different subject-specific potentials and needs, and they differ greatly in their personal development. Since teachers often lack the to appropriate concepts to better pay attention to these students, individual and diagnosis-based support for these students has so far rarely taken place in school practice. Studies show, however, that a good match between the individual learning starting situation and the respective teaching offer is an indispensable prerequisite for exploiting performance potential. Thus, it is necessary to develop adaptive diagnosis-based support concepts that can be adapted to daily school practice and that take the complex set of conditions into account. Existing models of giftedness still lack a biology-specific dimension. However, studies have shown that giftedness is subject-specific. For an optimal support of gifted students in the regular biology classroom, it is therefore necessary to clarify first what basic understanding to experienced biology teachers have of giftedness in general and of biology-related giftedness in particular. How do experienced biology teachers characterize successful biologically gifted students and successful biologically professionals? What role do experienced biology teachers attribute to the variables, interests, and motivations with respect to the development of potential of biologically gifted students? And which subject-related competencies, federal educational standards of students do teachers see as an indicator or indicators for biology-related giftedness? This presentation focuses on question 1 and 4. The sample consists of 35 in the first part and 23 in the second part, secondary school biology teachers of 70 invited biology teachers among 10 schools involved in the STEM biology sub-project, whom the majority was female. All teachers met the following criteria. First, degree in biology. Second, teaching biology or natural science subjects. Third, at least 3 years of professional experience. To answer the research questions, an anonymous online survey was conducted among these 10 schools involved in the STEM biology sub-project. Based on established criteria, a total number of 70 teachers received a letter of invitation to participate in the study. Of these, 35 in the first and 23 in the second part responded, respectively, and were included in the study. The letter included an internet link to the online survey, and the participation was voluntary. The respondent completed a 2-part questionnaire. The first part included 7 open-ended questions about the perspectives of biology teachers related to general and biological giftedness. The second part was related to the German federal education standards in biology, which were assessed by the participants using a 6-point Likert scale to the questions: how strongly do you see these items as an indicator of the overall construct of biology-related giftedness? At the end of the survey, different background information was requested, and it took approximately 30 to 60 minutes to answer the questionnaire. Now I will show you the first results of the 2-part questionnaires, which is divided into 2 parts. Part 1 shows perspectives on biological giftedness, and the second part is about the assessed suitability of the German federal education standards in biology as indicators of biological giftedness. The survey is subject to the mixed method approach, meaning that both elements of qualitative and quantitative analysis are used for analysis. Data of the first part were analyzed using qualitative content analysis with MaxQDA. The purpose of qualitative content analysis is to make replicable and valid inferences from a text. The analysis was carried out in an inductive-oriented manner, as all the codes were derived from the data. The purpose was to capture biology teachers' perspective on biological giftedness. The data of the second part were analyzed quantitatively with PRISM. First, a descriptive data analysis was performed to calculate the mean, median, and mode values, as well as the standard deviation. As a second part, the items were ranked according to the highest agreement with the 4 areas competences of the Federal Educational Standards in Biology. This is subject knowledge, scientific inquiry, scientific communication, and decision making. The qualitative content analysis for the first survey part resulted in a total of 4 main categories with 2 to 8 subcategories for the question on biology-related giftedness. Some of these are shown as an example here in Table 1. It can be seen that interest and the basic understanding of biological relationships are important factors for giftedness. In addition, the biology teachers mentioned the networked and the independent thinking of learners, as well as the urge to learn more and to work determinedly on it as other important factors for giftedness. In the second part, the biology teachers were asked to rate how strongly they consider standards of the German Federal Educational Standards in Biology as an indicator of the overall construct of biology-related giftedness. Here you can see 3 educational standards that the biology teachers from the sample see as the most important, the most appropriate indicators of biological giftedness, on the left-hand side in blue. On the other side, you see 3 educational standards that biology teachers consider to be the least appropriate indicators of biological giftedness, on the right-hand side in green. Interestingly, items from the competency area of decision-making are considered more important by the teachers surveyed than, for example, subject knowledge. Results of the qualitative content analysis of the first part of the online survey show that the biology teachers consider, among other things, interest in biological contents as an important prerequisite for giftedness. In addition, the respondents distinguished between subject-specific characteristics, for example, diversity of topics and the presence of cognitive skills, as well as process-oriented competences aiming at scientific thinking and inquiry. Analysis of the second part of the survey shows that the German federal educational standards in biology can be used in part as indicators for biological giftedness. It is particularly striking that among the standards considered most appropriate as indicators of giftedness, process-related competences are primarily reported. Above all, biology teachers evaluate standards from the competency area of decision-making as indicators of biological giftedness. These results are interesting in the context of the research on science giftedness. For example, Picor and Dimitropoulos also emphasize that prominent role of process-related skills like creating, analyzing, and evaluating for scientific giftedness. Further analysis should provide information on which concrete competencies of the educational standards in biology the teachers refer in their open answers, and which commonalities, differences, and peculiarities exist with regard to general models of giftedness. Overall, the results may help to inform approaches to identifying and promoting biological giftedness away from special enrichment programs in regular classroom as well. Thank you for your attention.